So very good presentation, I would say. Anil has put a very neat introduction to my presentation. I was thinking, very apt. There was one question, right? So how are this audience going to be? What level we should start with? But I still concentrated on CAS, right? But very nice recollection of what's happening on storage side for last 3-4 years. We'll probably wait for when recording has to be started. So one question that came up on Flocker, right? I just wanted to comment. Flocker is along the timelines of Docker and Kubernetes, they started doing very well. There was good adoption, and it is open source mainly. And Kubernetes persistent volumes became a standard, right? Everybody wants to use a standard that's part of Kubernetes, right? And cluster HQ's Flocker plugin was an external one. Yeah, so I'm good. Thank you. All right. All right. A bit of an introduction about me. Good morning, good afternoon, everyone. I am Uma from MyData. I'm one of the co-founders of the company. I manage the operations right now, but we used to be known as CloudByte for the last 5 years. And we started from the backgrounds of NetApp and EMC in Bangalore. So this is a completely, formed at Bangalore and then moved to the Valley. It's a Valley company, but all the development team is here. And I'm going to talk about mainly where Anil has left out, right? Anil basically started at, there is container and there is storage array. How do you connect each other, and containers are taking the world off, and what do we do with connectivity to the persistent storage? I'm really going to talk about, what about arrays themselves, right? There is containerization of applications that are happening, but storage, what's the next level of technology that's happening, and mainly driven by CNCF, right? So that's container attached storage. So it's a new kind of an array itself you can consider, and it's completely open source. So we'll go quickly about what, why, and really how. How really means, it's super implementation details. I may not be able to talk, but I'll just give a benefit of what CAS is going to do to you as, as a business owner of IT or something. And that's an example of blue-green deployment, right? So let's talk a little bit about, who we are. And we are now known as MyData. MyData, our tagline really is, we deliver data agility, right? And agility because, that's the new key, containers, right? You want to be able to deploy everything just like that. There's no upgrades, upgrade scheduling. Everything is like DevOps oriented. Similarly, what about the data, right? And one thing that, why this entire orchestration engines are taken off is really because, it's anti-cloud lock-in, right? Earlier, you move your application to Amazon, you are stuck to how Amazon manages your application, right? You cannot move to Google later on. And with Kubernetes, everybody is saying, I'm giving Kubernetes as a service, right? You tune your application to Kubernetes or Mesosphere, and then you can just move from any cloud to any cloud, or on-prem. You can move back from on-prem to a cloud or cloud to on-prem, all that stuff, right? So that is agile. What about data, right? So we are really defining a framework, and we are leading the way forward to apply the same to the data, right? And we were formerly known as CloudByte, and we are running a project called OpenEBS, Open Elastic Blob Store, right? And a lot of answers to Anil's questions that he asked himself in the beginning. I was about to say that, Anil, do you know OpenEBS, right? So if it is a nascent project, a 1-year-old, right? And I'll talk a little bit about Litmus. And Litmus is really, like EMC is known for years, right? People know EMC and NetApp because of their stability. It's being used, but any new storage technology you bring in, how do you trust it, right? It is open source, for example, Ceph, Gluster, and all take time. So we also created a project called Litmus in order to really open up all the tests, right? And if you're an application developer and you want to use OpenEBS, you can actually put Litmus into your CI/CD pipeline and then really see how your application behaves, right? I'll talk a little bit about that. And we are one of the largest open source contributors group. My team itself is about 50, and there are more than 100 contributors right now. So we are proud to say that there's a lot of open source activity going on in Bangalore, right? And Maya Online is a kind of a SaaS platform control plane for all your Kubernetes control clusters put together where you can move the data in agile form, right? So we are growing. We started, we pivoted from Cloudbyte Elasticstore to open source oriented OpenEBS last January, and we have grown tremendously from there. We are a community about 5,000 people on GitHub, and on Slack we are about 800 people, right? Very active, and we have received, 50 of us are our own contributors, but there are additional 100 contributors. To get 100 contributors in an open source world is really something, right? And there is Hackfest going on right now, right? So if some of you are interested in learning a little bit more about what OpenEBS, please try to get in. And we released the first project for usage last KubeCon, December, so it's about 4 or 5 months. We already have about 1 million Docker pulls out of it, right? And we are also the company behind Litmus. This is also recognized by CNCF. Last month, CNCF has started a work group called Chaos Engineering, right? So Chaos Engineering is the answer to put your containers into a real production, right? So there's a lot of tools that need to be available to make sure that you're doing the right thing in this very agile world. So Chaos Engineering is picking up, and Litmus is expected to be the answer for Chaos Engineering of stateful applications, right? And what it does really is, it extends your CI/CD pipeline, right? You write your application, you take it through certain tests, and then put it into production. But now you're, microservicing that application, and you're using some storage underneath. So how do you really make sure that it's going to succeed for all the chaos, right? What we do is, you ask Litmus to come into your pipeline and then pick, I want chaos in the node level, chaos in network level, chaos in the application, chaos in the data level, and then it just goes and then does all that monkey stuff, right, in the pipeline, and then you can observe how your application is behaving. If your application withstands, irrespective of all the chaos that is introduced, you're good to go, right? So that's the idea behind it. It's a very nascent project, and it is born out of our test framework, right? We have a BDD and E2E framework within the organization, of course, which is open. And we thought, why don't we make it as a framework for everybody to use? For example, even Portworx can use, for example, right? So they have something called Torpedo, right? It's a very similar framework. This is something similar to that. So let me get to the crux of what CAS is, right? How many of you know DAS and NAS? I should ask how many don't know, right? So I should be careful. Anil is really near to me. Hey, what are you talking about? Right? So, so it's a new architecture, right? It's a new architecture through which the storage arrays can be developed, right? And it's applicable only to containers. That's why it's container attached storage, right? So, but I'm still going to go through what really CAS is with respect to DAS and distributed software, right? So really, CAS started as a kind of a next question to what the previous speaker has said, right? A data mobility problem, right? And a container moves from one node to another node. What happens, right? and you need to start engineering your solutions. Kubernetes doesn't want to answer that solution. Kubernetes is now answering how to connect the container to the storage, but it does not really answer how do I really make sure the data becomes available, and then the end-to-end data solution is taken care. So we started thinking about what if the storage for container native application itself is container native, right? All these problems of mobility for data can be resolved by data also being mobile, right? So that's where we said, let's containerize the storage also, right? So where is the data right now? Data is being exposed by an array outside, right? And I'll talk about a lot of trends, why the storage arrays are not great. And in the virtual machines world, virtualization world, we have seen two big technologies that have taken up, Nutanix and vSAN, right? So that's hyperconverged, right? Hyperconverged can be thought of as a key driver to the hybrid cloud solutions, right? And DAS is still popular, NAS is still popular, but this trend has been coming up again and again in terms of how the technologies are being chosen, whether do I go with the SAN or do I go with the hyperconverged. So I would vote for hyperconverged is the predominant technology that is being used in the container world for deployment, right? So, but Nutanix is not open source, vSAN is not open source. Why do we think Kubernetes is so popular? Docker is so popular? Why these standards are being adopted so fast? The single answer is it's open source, right? So we thought let's do the same type in open source at the storage layer, right? So we have a couple of open source popular solutions. Gluster is one of them, Ceph is another, right? For file and block, I would say. And these are not really built for containers, right? You're trying to fit them for container. Of course, you're writing plugins to connect and all, and CNS. I would say they did a good job of containerizing some of it at the controller level, et cetera, and now we are working towards another new standard called NDM, Node Disk Manager, along with the folks and friends at Red Hat on how do you really standardize accessing the disks, right? You have standardized how to access the volume, but how do you really standardize the disks, right? What does disk really mean at Kubernetes, right? So that's another effort that's going on, which may not be part of this topic. So let's talk about storage trends. Why we think shared storage is not the answer. I mean, this is a trend that's already proven. It used to accelerate your storage, right? We used to have SAS disks, and later SSD came. Then everybody wants to go to SAN because they're fast, right? Now you have direct attached storage, all NVMe disks and all, which are more faster than your SAN itself, right? You get millions of IOPS out of a single disk, right? And so, DAS is, I want faster storage, I'll go with a direct disk, right? And it used to say that SAN is the only way I need to put my banking data, right? It's resilient, right? A disk goes, everything. But now we are moving towards microservices, right? And I want 100% good latency and everything, and I have a big sandbox. Sandbox really means that multiple cluster. If one cluster node goes down inside the SAN, you are talking about blast radius, right? Till that node comes back up, the entire thing is slow. I mean, there are solutions that are being managed, but microservices world, that's not acceptable, right? And we used to talk about, okay, I'm going to put a sandbox as a silo to an application. But now you're talking about microservices where, he talked about few hundreds of containers, but, a container cluster of size 100 to 200 is very normal, right? And an application of size 100 containers, right? A single application is now broken into 100 containers because everything is a service. You cannot run two processes inside a container. Just move them to two containers, right? So it's easy to have an application with 100 processes, a real enterprise application. Now you're running them as 100 containers. So there is a container sprawl everywhere, right? So I don't want to run silos, right? So I want to be able to manage in my 200 Kubernetes node cluster, right, run some 10 applications, right? So that's why shared storage is not really the answer, right? And let's look at the DAS versus distributed, right? So these are some of the companies that we interviewed, and we came to know that they are really using DAS, and these applications have been written to take care of some of the data protection features inside them. For example, a lot of databases do the replication themselves, right? And they do the snapshotting themselves, right? So they just need the disk, which is very, very fast, right? So Netflix and Netflix is one of the example. Apple runs a very huge cluster with DAS, right? And the good part about DAS is really it's simple. It's really, really fast, and because you are writing directly to the disk, right? And capacity planning, yes, you need storage. You keep doing better and better things. The concern is, you need to have deep pockets, right? The utilization is really less than 100%, 10% sometimes, right? The worst case scenario, and difficult to manage, and that's where this hyperconverged solutions have become very successful, right? All the disks are with your node, and there are 100 nodes, and how do you manage your applications or containers to, schedule them in such a way that the storage is really utilized well, right? Let's talk about distributed. Right? Distributed is also most of the arrays that we have today are kind of a distributed. The recent wave is about scale-out storage, right? So scale-out storage is good for large enterprises because it's got centralized management. You don't need to worry about, as your demand grows, you can keep adding nodes, and then you get all these things, right? And then they also bring out this storage enterprise features, snapshotting, cloning, replication, all that stuff. The concern really is the complexity, and the main concern for container world is the blast radius, right? So just like you're versioning your application, whenever you move to anywhere to any node to any node, the stateful application, the underlying performance is expected to be stable, right? Otherwise, containers cannot take off, right? So blast radius is a big problem, and that's why vendors are again and again thinking, is the distributed and shared storage is really the answer for me. And the containers are still evolving. Of course, everybody's trying to use the underlying technology to get started, but I'm just talking about why CAS is better than, why CAS is needed, right? So DAS, distributed, both have some advantages, but for containers, both have some disadvantages as well. Just to summarize, we coined the term called YAS, yet another scale-out storage system, right? And we don't want to give another YAS, right? If I'm giving another solution as an answer to all the previous problems, right? In YAS, we have this, it's not tunable for containers. Your containers are hundreds in number, and your array is somewhere else, right? How do you tune your storage for container underneath, right? And this is monolithic, right? Array is like all containers are going to write into monolithic, and you can consider cloud itself as another big monolithic itself, right? So what we need is something that's container friendly, but not really another blast radius system, right? So we want it to be like DAS, because DAS is fast and simple, and leading towards hyperconvergence as an answer, right? And it should not have blast radius, right? And it should be container friendly, right? And we didn't want to solve the problem of how do you access the storage. That's being resolved by CSI, and some of the early entrants has faced those problems, Rexray itself, right? Rexray was initiated with a great enthusiasm, but with CSI coming in, you're almost competing, right? And similarly, it happened with Flocker technology as well. So I think CSI is going to take off, in my opinion, right? And every vendor, as far as I know, is already writing plugins to CSI, right? And we are delivering one next month. So what is really CAS? Container attached storage, right? So you take the storage and you are really attached it to a container, right? And before we go further, it has to have all advantages of DAS. Simplicity, fast, right? And it's right there for me, right? And we want to take good parts of distributed storage, good parts being it's reliable, right? You can take snapshots, clone, but I want to leave out some of this part, right? This is mostly the blast radius thing, right? When some node fails, my stateful application should continue to work the way it's been working, right? And that's really the CAS. And there's a lot more advantages of CAS apart from just DAS and distributed, right? And we'll talk about that in a while, right? So CAS, before I really talk about the CAS architecture, right? So the storage itself should be tunable for container, right? And one of the main things that we heard is cross-cloud portability, right? The moment you're writing, one of the solutions that Anil talked about is use NAS, sorry, NFS as a mobile problem, right? Data mobile problem, you can use NFS, or you can use cloud disks. So you are going to cloud because Kubernetes or Mesosphere is there, Kubernetes service. You tune your application for Kubernetes, great. And where do you write your data? Into Google Cloud. Now after 1 year, all your data is in Google. And you have super duper Kubernetes and you want to move away, right, for whatever reason, right? And then your data is already there, right? So cross-cloud portability is the biggest need, and that's why we are talking about CAS, right? And cross-SAN portability, but I would say, like these two are the key things, right? We needed to put something around the slide, so we coined the terms. So let's talk about CAS, what really CAS is, right? So it needs to remain simple as a DAS, and then reduces or eliminates cloud vendor lock-in, right? And it's easily cross-cloud, and it has to be in open source. That's where it has to, it gets adoption, right? So CAS is nothing but the normal stuff, right? You have multiple pods in a non-CAS architecture, storage array, right? You have multiple pods that are coming out, and the storage is still going to be somewhere outside your cluster, right? Coming from a storage array, right? In storage really means there is a storage controller. If you are, we are at SNIA, so I'm assuming some kind of a storage knowledge here. Storage volume really means it's coming out of a storage controller, and there are multiple replicas, right? When something goes down, you have availability of data from another replica, right? But it's all going to be, let's say that a storage controller is the guy who is giving the data to you. The volume is really coming from storage controller, right? And I have 10,000 containers spread across 200 nodes in my Kubernetes cluster, and I'm using a very big storage array, like 5 racks, and it's super fast, but it's all 1 or 2 redundant 3 storage controllers, right? And that's not really CAS. CAS is really, you take a storage controller, you spawn a storage controller, and give it to the container itself as a volume, right? Think of it as this networking virtual switches, right? You are not going to have a big switch. Now, in this SDN world, you want a VLAN. I have a switch, take it, right, put next to it, right? Something very similar, right? The CAS is nothing but instantiate a storage controller every time you ask a volume, right? And now, because you have one storage controller defined for your volume itself, you don't need to really be so smart about 100 workloads being managed by storage controller, because one volume, one storage controller. If storage controller needs compression, the entire application needs compression, the entire storage controller is just doing compression, right? So the complexity within the storage controller becomes very, very less because you're only serving one application, right? So that's the idea of containers itself, right? You don't need to know about a lot of things, right? I'm running 100 containers, and 100 are doing 100 different jobs, right? They're all of different versions. And that's exactly the idea we are trying to bring to storage, right? So that's where we did our own implementation, OpenEBS like that, and then we are giving it out as a general architecture, container attached storage architecture. CNCF seems to have liked it, and they have published a CAS blog on the CNCF main blog itself. And we are trying to be part of the foundation, just like CSI is taking the container connectivity, storage, and array architecture itself could be CAS. So we are trying to see, I think Portworx to some extent, and storage, OS, and there are some startups in this ecosystem, storage thing. So we are trying to see, if they are also can be called CAS or not. Right? So CAS benefits, workloads much smaller, right? In the real world, the workload is very, very small because it's just a container. The answer to that is that, keep the data local, right? You don't need to worry about managing big data, right? And ephemeral duration, containers, even stateful application, he talked about it, right? So it's running on this node for no reason, Kubernetes moves it elsewhere, right? So the answer to that is you run your controller also in a pod, right? You just move your controller also, right? You spin your controller. So basically in CAS architecture, storage controller is a stateless application, right? And it just takes the metadata through a manifest, right? And I can spin up a storage controller. Storage controller is nothing but, it has to expose a target. For example, iSCSI target for block storage, right? And you spin up an iSCSI target in a container, and wherever your application moves, I move there itself, so there's a connectivity there. And target you make, the controller pod is intelligent to know where the underlying replicas are, right? And fortunately, along with the storage technology, Kubernetes also is evolving, right? There is like a storage affinity. You can now tell a pod to be scheduled on a particular node, or affinity, node affinity is being part of it, and volume topology is being built in. It's a community work, right? So we go and say that this is becoming a problem, so why don't I contribute this feature to Kubernetes itself, right? I keep calling Kubernetes again and again, but because this architecture can be applicable for other container technologies as well, right? So there is 10 to 100x increase in containers. What it really means that you have one application, you now have 10 containers or 100 containers for the same application when you microservice it. The answer to that is that no worries, right? So it does not cost anything to instantiate a storage controller. It's just like another container, and then you get it, right? So mobile workloads, you follow the workloads because it's in a pod, right? And immutable or immutable, right? Once the workload is instantiated, it's immutable. That means you cannot change it. You have to restart the container, right? So because the storage controller itself is stateless, and that's not a problem for me. So I'm just going to run a little bit fast. You must have got an idea of what CAS is right now, right? So this is an example of a CAS architecture, right? So I am still putting cloud disks because what happens if I'm running my application on cloud? Somebody might ask. But let's take bare metal or private cloud as an example, right? So you got multiple application pods running, right? So PVC is the persistent volume claim. This is the Kubernetes way of connecting, right? And when it moves to CSI, the same thing will be applicable, right? So instead of giving a volume to a pod, we are giving the entire CAS, right? A CAS is nothing but one controller pod and a set of replica pods. This entire thing is really giving. So it adds to the container sprawl. For example, I have one container, I need one volume. Now volume really is like 4 containers, one controller container and then 3 replica containers. But hey, like we are in this world where number of containers is not a problem anymore, right? So, and this is how it's going to look like. And application pod, each replica pod will be stationed in different nodes for the obvious availability reasons, right? And this is the crux of entire CAS, right? Your storage array is within your Kubernetes cluster, and how many storage arrays are there? Maybe thousands, right? And what does this really do to you, right? So how many of you have heard of blue-green deployment upgrades, right? A bunch of them, great. So there are two problems in the real upgrade, right? So one is stateful application upgrade itself. I'm running MySQL database, right? And there are 1,000 users using that application. So how do I upgrade, right? You have to do some blue-green deployment where you try to instantiate a new application in place of with a new one, and then switch the control to that and get back, right? The other one where the storage arrays vendors and users are aware of is upgrading a storage array is a big deal, right? I have a banking application running, a real-time critical application. Now I need to do an upgrade of it, right? And it is a big deal, right? Because it's one storage controller, 1,000 volumes, and 999 volumes go fine. Just one does not go. Still, the CEO of that bank calls you, right? He does not care, 99 went fine, right? So that's where we are, CAS is a real good fit for that because 1,000 applications, 1,000 volumes, you have 1,000 storage controller. You do one at a time. You ask the CEO, if this is very critical, leave it, right? I will take an upgrade of another 999 controllers, right? So let's do a quick example of how it is. I want to give 5 minutes for Q&A as well, right? So let's say I have multiple volumes, right? And I want to upgrade. We have this operator concept where, OpenEBS, even though we have multiple storage controller, there is still a guy who manages the entire control plane, and we call it as my operator. And the administrator can say that, let's upgrade some of them, right? And these are some of the ones that are chosen. And MySQL is running, for example, this one is still not upgraded earlier, right? This is unimaginable for the regular storage controllers. And I'm using MySQL, I want to upgrade from 1.2 to 1.3, and then, I spawn a new pod, right? And 1.2 continues to do that, and then I switch that to this. All replicas are connected to that, and things go fine. And now I need to start upgrading this replica, right? And replica is like you bring down the replica because there are two other replicas, right? And if the replica upgrade goes fine, you can rebuild it. So you just go one by one, right? The same way. And then you go to the next application, right? So that's the major idea of it, right? So with CAS architecture, the upgrade itself can be automated. You don't need like 5 people on call and a lot of planning, right? You can put that into your DevOps thing with Litmus in the middle. You can automate all your things, right? You upgrade and test the data. If it is good, you proceed, otherwise revert, and then continue on it. At the end of the application, right, so upgrade, half of the volumes are upgraded because we found that the software is not good enough for other half of the volumes and they're still running, right? So this kind of a huge flexibility can kick in, right? And that's something that's not even imaginable in our traditional world, right? Like we lived the world for 5 years, right? So this is just an initial introduction, right, of CAS, and we are also working on speed, right? And one of the things that the data still has to go through the kernel, right? Storage controller pod, replica pod, and the kernel is again a big monolith, right? And with CAS, the entire storage is brought up to user space, right? And we don't run any storage software in kernel. If you run, then you cannot upgrade, right? You cannot put it into container, right? So then what about the performance, right? So we are SPDK enabling, SPDK is the answer, right? And there are other technologies from Cisco. I mean, SPDK is mainly driven by Intel, for example. FDIO VPP is a Cisco architecture. They are solving these problems in networking. And then we are trying to apply them to the storage as well. And we have already open sourced one of such efforts, which is called a vhost user. And it's really a complex piece, and it is open source. So if some of you are storage developers, enthusiasts, architects, please take a look at it. And we see this as the future, right? Open source is the future. Everybody has to embrace open source, even the biggest of biggest vendors, right? So there is a blog published about what I just talked. Our blog has been published on the CNCF itself, and just as a credibility that it is being adopted at a highest foundation level. And with CAS and OpenEBS as a reference implementation, the end result should be, storage should not remain as a concern and a big deal, right? So application upgrades are not a concern because they are in containers. Same thing should happen to the storage. Right? So that's the idea I had, and hopefully, you appreciated it. I can take some questions now. Yes, sir.
Hi, just for mounting a volume, then when you convert that into a pod, so you are looking at consuming a lot of CPU and RAM as well for just mounting a volume.
Right. So mounting a volume, you used to consume the CPU in an array now, right? Array also used to have an SDC, a controller, and then replicas. It all used to be part of the storage array. Now you are bringing into the storage, Kubernetes cluster itself.
Yeah, but the cluster itself will be loaded to such a point for just mounting one volume then.
Right. That's true for containers themselves, right? There is a 100x on the number of containers that are needed, right? So that's true. There is a containers problem, and industry seems to be accepting it, right? And you will definitely run at least 10 times the number of containers than one VM, right? And overall, with respect to the storage efficiency and the utilization, it should sum out well.
So the volume is mounted based on a replica set, or do you have a replica set for mounting the
Right, we define it as a replica set, the entire storage controller. The storage controller again is like controller is not, it's a pod, right? And this replicas can be defined as a replica set. They go on each node, yeah.
Thank you.
Yes. It goes to the disk. I put SAN again because SAN becomes a local disk, right? Or cloud disk becomes a local disk. These are more suited for hybrid clouds where the disk remains local, right? And there are technologies coming up with PCI Express switches as well, right? You can attach really local disk as an extension, and you can partition the disk in such a way that you take only 10 GB out of a 200 GB disk, right? But they are local disk. Right? The data will go through local disk, and there's not a great interface right now defined, and that's why we are defining that node disk manager. How do you manage so many disks underneath? What's the standard? So we are trying to contribute upstream into the Kubernetes itself, and Red Hat and Google seems to be supporting that idea. We are still in the design phase. The whole idea is that orchestrator knows how to manage your disks, how to manage your storage controllers, replicas, and then application pods as well. Right? Everything is controllable. Looks like we are out of time. I can take the questions outside.
One last question.
Sure.
You did mention about the upgrade path, right? Like if you basically give out around 1,000 CAS to that application pods, and you mentioned about the benefits of the upgrade, that you can individually upgrade. But at the same point of time, consider a situation where you want to deploy a security fix to the entire infrastructure. And when you want to upgrade all the volumes, all the CAS. So do you foresee any kind of bottleneck in terms of upgrading everything
it's
at
not,
one go?
I think it's still a flexibility. It's not a security fix for storage, right? Yes, and good thing is that security fix needs to be applied now, and you still need to wait for downtime, right? It might take a day to get the downtime. But now with CAS, you can just automate, we go to the extent of asking the administrators or the owners of the application, I need a fix, go ahead, I don't care, right? So you can automate, and then within a span of hour, right, half of them may be upgraded, and then you wait for other ones. It's more of a flexibility. And of course, instead of one storage array, you have 1,000 storage arrays. You can consider, there are some cases if you need to automate a lot of these things, right? But once that investment is done in production, you're getting a lot of benefits. I'll still be available. Thank you very much for your time. I hope I added some value, right? I'll be outside and can take some questions. Thank you very much.